Welcome to Scientific Concepts. We are going to discuss very interesting questions today. First question is there any parts of our body that get oxygen directly from the air, not from the blood? The answer is yes. We have skin and outer surface of our eyes. The outer surface of our skin and the outer surface of our eyes are in direct contact with the air. The oxygen can directly passively diffuse into our body, but there is a need of larger and larger amounts of oxygen, and oxygen must diffuse to each and every cell and organelle of the body. For this purpose, fortunately, we have lungs that can actively pull in oxygen and transfer it to the blood. It allows the body to transfer the oxygen to each and every single cell of the body. As we know, eyes are the organs that can see. In order to make a vision, there must be no blood in the front part of the eyes, and eyes must be transparent to let light shine into the eyes. If there is a blood in front part of the eyes, would be blinded. The outer part of the eyes allows the light to get in, and also it allows the focusing the light into images. Therefore, these parts must be transparent. Same way, the outer layer of the skin absorbs oxygen directly from the atmosphere, even though it doesn't have to be transparent like cornea. It's an efficiency standpoint that the outer part of the skin will absorb some of the oxygen directly from the air, and the rest of the oxygen will be absorbed by blood. The next question is, can humans ever directly see a photon? The answer is yes. In fact, the photons are the only things that we can see. The only thing that a human eye can detect is light, and photon is a bit of light. On the inner surface of the eye, there are rods and cones present. They absorb photons one by one. When you look at a chair, you are not actually seeing a chair. In fact, you see a bunch of photons that have reflected off the chair. When light reflects off the chair, the photons arrange into a pattern that resembles the chair. When those photons strike a retina, our cone and rod cells detect the same pattern and they send it to our brain. So our brain detects it as a chair, while we are really looking at a bunch of photons. Our eyes can really see a bunch of photons. Can our eyes see an isolated photon? Although the rods and cones in our eyes can detect a single photon, but the neural circuitry in our eyes only passes a single photon to the brain if there are a bunch of photons present in the neighboring rod cells. Therefore, even though our eyes are capable of detecting a single photon, but our brain is not capable of receiving it. The next question is, do I turn on more parts of my brain and get smarter? Answer is no. Turning on more parts of our brain doesn't make us smarter, because the brain doesn't work like this. An example of higher activation of brain is seizures. An extreme activation of brain leads to seizures, and during a seizure, a person experiences severely decreased functioning and mental capabilities. A person with a seizure might not be able to talk, walk, and do math problem. The analogy that the brain works like a computer is completely wrong. Standard microchip computers are deterministic, linear, and have localized processing operations. Such type of processing is excellent for doing long mathematical calculations and carrying out deterministic actions such as displaying photos and editing text documents. However, this type of processing is terrible at generating creativity, recognizing patterns in complex systems, attaching value to information, extrapolating complex trends, learning new skills, and generalizing data into a small set of principles, such as our brain does. In contrast to computers, the brain is non-deterministic, asynchronous, non-linear, and has delocalized processing operations. Hence, we get to know that the brain is really the opposite of traditional microchip computer. Brain is good at generating creativity, recognizing patterns, evaluating information, extrapolating trends, learning new skills, and generalizing the data, but it is bad at doing long numerical calculations. Since a computer is linear and deterministic, you can make it more powerful simply by installing more processor and extra RAM. In contrast, the brain is non-linear and non-deterministic, so turning on more neurons at once won't make you more smarter. The next question is why the raindrops are tear-shaped. Answer is raindrops are not tear-shaped. When falling through the air, they are approximately round. What makes their shape as a teardrop is friction, the force of friction. Any object has enough friction to drag some of the water back from the tail of the raindrop, so they are round in air and are tear-shaped at some surface, as the air doesn't have any friction.